Okay, just going to have a look at a couple of examples. So the first one, for each of the following relations, state the coordinates of the vertex and sketch the graph stating the domain and range. So for the first one, okay, remember our general equation looks like that. So our vertex is at HK. Okay, so we're going to have, in this case, it's going to be H, which is -2. Okay, opposites. And positive K, which is 1. Okay, the H, we can say minus H equals 2, so H equals -2 in this case. So that's our turning point for a vertex. Our x-intercept, we let y equal 0, so 0, take 1 squared equals 8, x plus 2. Minus 1 squared is 1, 8x plus 16. Okay, take 16 across. Oops, minus 15 equals 8x, so x minus 15 on 8. Okay, so our x-intercept looks like that. Y-intercepts, so that was our x. Our y-intercepts, we let x equals 0. Okay, 2 times 8, so we get 16. And over here, 1 take y, y take 1 squared equals 16. So y take 1 equals plus or minus the square root of 16. So it's plus or minus 4. So either y equals minus 5 or y, minus 3, or y equals 7, positive 7. So adding 1 to both. So there are our two y-intercepts. Okay, a bit different this time. We've got two y-intercepts instead of two x-intercepts. So we can graph that, okay, just as a rough, quick little sketch. Okay, put our points in, minus 15 on 8. Well, that's roughly about almost at -2. And we've got -3, which is down here somewhere, and positive 7 up here somewhere. Just connect the dots. And just label them. Okay, there we go. Now we've got a turning point, don't forget, at -2, positive 1. Okay, because they've given us, we might as well put that number in as well. So that's that first example. Let's have a look at the second example. So we've got y squared equals 6 take 3x. I'm actually going to rewrite that as 3 times 2 take x, just to simplify it a little bit. So we say y squared equals that. Actually, I'll take -3 out. So that'll be -2 plus x. Okay. All I've done is rearrange this equation. Y takes 0, the same as y squared, but now I have something that looks like that. Okay, so my vertex is going to be at 0, it's going to be 2, 0. Okay, opposite 2 and 0, doesn't change. My x-intercept, okay, let y equal 0, so 0 squared equals 6 take 3x. So x has to be 2. And my y-intercepts, we let x equal 0. So y squared equals 6, take 3 times 0. Okay, y squared equals 6, y equals plus or minus the square root of 6. So I'm just going to leave that there. Got a few points, let's put them in. We've got x-intercept at positive 2, plus or minus square root of 6. And a turning point at 2, 0, which is at the x-intercept. Okay, and that's it. Okay, so that's example 12. Example 13. Determine the equation of the relation with rule. Okay, we've got our y take k squared equals a, x take h. We have a vertex at 3, 5, and it passes through the point 5, 3. Okay, just putting all my information down. So first thing, we know the vertex is 3, 5. So we can say our equation is going to be y take 5 squared equals a, x take 3. Okay, just putting those points in for our h and k. From here, just need to find what that a is, and we use that by using the 0.53. So we let x equals 5, y equals 3. So just putting those two numbers in. Simplified a little bit, 3 take 5, so minus 2 squared a times 2. So positive 4 equals 2a, so we can say a equals positive 2. So my equation becomes y equals 2, no it doesn't, y take 5 squared equals 2 times x take 3. That's it. So that's part A. Part B, determine the equation of the sideways parabola, which contains the 3 points 0, 0, 0, minus 4, and 3, 2. Okay, so I've got 3 points. 2 of the points given, 0, 0, and 0, minus 4, both lie on the y-axis. So the axis of symmetry is going to be midway between these 2 points. So axis of symmetry is going to be midway between those 2 points. Y equals our second, or first plus our second divided by 2. It's halfway between them, so minus 4 plus 0 over 2 is just minus 2. So there's my axis of symmetry. So y equals minus 2 is the equation of the axis of symmetry. Now, we know our general equation, y take k squared equals a, x take h. And we know the axis of symmetry is minus 2, so that indicates that we've actually got y plus 2 squared equals a, x take h. Okay, because that's how much we've been moved up. Now, or actually in this case down. So now we've got to use another point. So let's use 0, 0. Okay, and hopefully that'll help us find a. We need to find h as well. So hopefully we can use either of those. So y equals 0, just put those 2 points in. 2 squared is 4, so it'll be minus AH. I can't do much else with that. Okay, let's use the point 32. So x equals 3, y equals 2. So 2 plus 2 squared equals a. Now x is 3 minus h. And 2 plus 2 squared is 4 squared, which is 16. It'll be 3a take a h. So now we've got two equations and we can simultaneously equate those using simultaneous equations. So we'll say equation 2 take away equation 1. Oops, that should be a 2. So equation 2 take away equation 1. So we'll have 16 take 4 equals 3a, okay, take nothing, and we have minus AH take away negative AH. Okay, lots of negatives in here. We've got our equation 2 is there. Okay, minus AH. Take away equation 1, which is minus AH. Okay, let's use brackets there. Two negatives become positive. Negative plus that, they cancel out each other. So we get 12 equals 3a, so we can say a is actually 4. Let's put that back into equation 1. So 4 equals minus 4 times h. So h equals minus 1. Just got to restate my equation, so just on the side here, we'll say y plus 2 squared equals a, 4, x, and we've got minus 1. Okay, it becomes plus because we actually have minus h. Minus h is going to be positive. So that's my equation. Now it doesn't ask to sketch it. I'm not going to sketch it at this moment. So that's example 13. And in the next video we'll have a look at a couple more examples.